in this video, we are going to solve problems in first order differential equations. So we have this question. We are supposed to find y prime of hyperbolic cos x plus y hyperbolic sin x is equal to hyperbolic cos squared x. And then the boundary conditions are y of 0 is equal to 2. So the first thing is that we need to make the coefficient of y prime 1. So let's divide through by hyperbolic cos x. So y prime then plus y hyperbolic sin x divided by hyperbolic cos x is equal to hyperbolic cos squared x divided by hyperbolic cos x. So y prime then hyperbolic sin x divided by hyperbolic cos x is hyperbolic tan x. So plus y hyperbolic tan x equals cos x. So now we can find u of x, which is the integration factor. So u of x is equal to exponent integral of the coefficient of y, which in this case is hyperbolic tan x. However, dx. Now, what is integral of hyperbolic tan x dx? You see that this can be written as integral of hyperbolic sin x divided by hyperbolic cos x dx. And then now if you differentiate hyperbolic cos x, you will get hyperbolic sin x, and therefore this integral is equal to natural log of the absolute value of the denominator, which is hyperbolic cos x. Now I've already done a video on how to integrate hyperbolic functions. I will add it. I will put the link in the description so that you can look at it. So having gotten this, the next thing is that we are supposed to multiply through by the integration factor. So let me write the integration factor in proper. So u of x is equal to exponent natural log of the absolute value of cos x. So we are supposed to multiply this through. So it means that this becomes exponent natural log of cos x. And then, so let me put y prime here. So y prime exponent natural log of cos x, then plus y hyperbolic sin x exponent natural log of cos x, and then this is equal to cos x exponent natural log of the absolute value of cos x. So now you see that all of this can be written as d dx of exponent natural log of cos x then times y equals cos x then exponent natural log of the absolute value of cos x. Now look at this. If we maintain exponent natural log of cos x, that is this. If we differentiate y, we get y prime. Now if we maintain y and we differentiate exponent natural log of the absolute value of cos x, if we differentiate cos x, we get sin x and then repeat it. So our differentiation is correct. So it means that exponent natural log of the absolute value of cos x y is equal to cos x then exponent natural log of the absolute value of cos x and then dx. So actually there's a d here. So integral of the derivative of exponent natural log of the absolute value of cos x and then y is equal to the integral of cos x then exponent natural log of the absolute value of cos x. So if we continue from here, you see that this becomes exponent natural log of the absolute value of cos x y equals integral of cos x exponent natural log of the absolute value of cos x Now, we know that exponential log is equal to 1. So, exponential log of cos x is the same as cos x. So, this becomes cos xy equals integral of cos x times cos x will give us cos squared x dx. Sorry, I forgot a dx here. So, there's a dx here. So, now, how do we integrate cos squared x? We need to rewrite this in another form. But then we know that if this was a trig identity, for example, cos squared x, this is equal to half of 1 plus cos 2x. So we can use Osborn's rule to write this in terms of hyperbolic functions. So cos x, y. So let me bring the y first. So y cos x equals, so in terms of Osborn's rule, this becomes integral of half of into bracket 1 plus. Now Osborn's rule says that if you see cos a, replace it with hyperbolic cos a, and if you see sine a, replace it with I hyperbolic sine a. So this becomes cos squared x dx. So y cos x is equal to half, and then if you integrate 1, you will get x. 1 dx is the same as integral of dx, which is x. Sorry, here is cos 2x. Please, let's make the corrections. It is cos 2x, so here is cos 2x. Then if you integrate cos 2x, you will get plus 1 over 2, and then hyperbolic sine 2x plus the constant of integration. So y cos x is equal to half x plus 1 over 4 hyperbolic sine 2x plus c. Now, the boundary condition says that y of 0 is equal to 2. It means that wherever we see x, we should replace it with 0. And wherever we see y, we should replace it with 2. So we see that cos 0 is 1. So here becomes 2 times 1, which is 2, equals 1 over 2 times 0 is 0. Then plus 1 over 4. Hyperbolic sine of 2 times 0 is 0. So hyperbolic sine of 0 is also 0. So c is equal to 2. And therefore y cos x is equal to half x plus 1 over 4 hyperbolic sine 2x plus 2. So we got the equation as y cos x equals half x plus 1 over 4 sine 2x plus 2. Now, we know that hyperbolic sine 2x is equal to 2 hyperbolic sine x cos x. So y cos x is equal to half x then plus 1 over 4 times 2 hyperbolic sine x cos x, and then plus 2. So y cos x is equal to half x and plus, now this 2 and this 4 will cancel, so here we have 1 over 2 and hyperbolic sine x cos x and plus 2. So we will have to divide through by cos x. So y is equal to 1 over 2 cos x then plus half of, if we divide through cos x, this one will cancel, so we will have hyperbolic sine x and plus 2 over cos x. So we have y is equal to half x sec x then plus 2 sec x and plus half hyperbolic sine x. So if we group like terms, y is equal to half then x sec x, then plus hyperbolic sine x, and plus 2 sec x. The accompanying figure is a schematic diagram of a basic RL series electrical circuit that contains power source with a time-dependent voltage in volts, a resistor with a constant resistance of R in ohms, and an inductor with a constant inductor of L henries. A current of I of t in amperes flow through the circuit where I of t satisfies this differential equation, which is L di dt plus Ri equals V of t. Now the first part is find I of t, and then they've given us boundary conditions to find I of t. And the second part is what happens if the current stays over a long period of time. So we've seen the diagram. Now let's set up the differential equation. So the differential equation is L di dt plus R of I equals V of t. So if we divide through by L, we have di dt plus R over L I equals V divided by L. So from here we can find our integration factor U of x equals exponent integral of R over L dt. So if we integrate this, we see that the integration factor U of x is equal to exponent RT over L. So we can go ahead and then multiply through by the integration factor. So multiplying through by the integration factor, we'll get exponent R of L times t, then times di dt, and plus R over L I times exponent R of divided by L of t. Then this is equal to V divided by L exponent R divided by L times t. So you can see that this is the same as d dt of exponent R over L. Here's L. Here's L. Exponent R over LT times I. Because if you differentiate I, it is di dt, then exponent R of divided by L times t. And then here we keep I constant, so I is constant here. If you differentiate this, you get R over L, which is this. Then you repeat it, exponent R over LT. And this is equal to V divided by L, exponent R over LT. So exponent R over L t, then I is equal to integral of V divided by L exponent R over L times t. So we'll bring V over L out because it's a constant. So exponent R over L t is equal to V over L. Then, sorry, there's a dt here. I'm sorry. Then integral of exponent R over L t dt. Sorry, there's an I here. So exponent R over L t I equals V over L. If you integrate this, you have to multiply it by the inverse of this, because if you differentiate this, is R over L, so you have to multiply by L over R, then exponent R over L t plus the integration constant. So you see that exponent R over L t I is equal to this L and L will cancel out. So we have V over R times exponent R over L t plus the integration constant c. So now, if we make I of t the subject, you see that I is equal to, we are dividing through by exponent R of LT, so it will cancel this one. So we left with V over R here plus the constant times exponent minus R over LT. So this is the equation for I of t. Say that I of t is equal to V over R plus c exponent minus r over L times t. Now, if you read the first part of the question, it says that we should find I of t, and they've given us the boundary conditions. R is equal to 10 ohms, L is equal to 5 henries, and then 20 volts. And then I of 0 is equal to 0. So let's first find I of 0. So that means wherever we see t, we are supposed to insert 0. So I of 0 is equal to V over R, then plus C, then exponent. Now, t is 0. So exponent 0. So you see that, but I of 0 is 0. So in other words, 0 is equal to V over R, then plus C. So C is equal to minus V over R. So now I of t is equal to V over R, then minus V over R exponent minus R over L t. However, they give us the values of the other elements. So we know that I of t is equal to, the voltage was given as 20 volts, so 20 divided by the resistance is 10 ohms, then minus the voltage 20 divided by 10, then exponent. Here is the resistance, which is 10, so minus 10 divided by the inductance 5, then t. So I of t is equal to 10 divided by 20 divided by 10 is 2, minus 2 exponent 5 divided by 10 is 2, minus 2t. So this is I of t. And the second part says that what happens to the current over a long period of time. Now, as t approaches infinity, what happens? You see that if we put infinity here, this term, which is exponent minus 2t, this one will approach 0. So as t approaches infinity, I of t will approach 2 minus 0. So I of t will approach 2. So over a long period of time, the current will just be 2 amperes. Solve the differential equation tan x dy dx plus y equals tan x cosec x. So the first thing is the coefficient of dy dx must be 1. So let's divide through by tan x. So dy dx plus 1 over tan x y is equal to, this tan x will go away, so it will be cosec x. So now dy dx plus tan 1 divided by tan x is the same as cot x y. So instead of writing cot x y, let me write it as y cot x equals cosec x. Now we can find the integration factor u of x, which is equal to exponent integral of cot x dx. So u of x is equal to, now this cot x is the same as cos x divided by sin x. So let's do this, integral of cot x dx. So this is the same as integral of cos x divided by sin x dx. So if you differentiate sin x, you get cos x. So this is equal to natural log of the absolute value of sin x. So this is equal to integral of natural log of the absolute value of sin x. So if we multiply by through by the integration factor, so it becomes exponent natural log of the absolute value of sin x dy dx and plus 1 over tan x, then y, then exponent natural log of absolute value of sin x, and this is equal to cosec x, and then exponent natural log of the absolute value of sin x. So now this is equal to d dx of exponent natural log of the absolute value of sin x y. Then this is equal to cosec x exponent natural log of the absolute value of sin x. So now exponent natural log of the absolute value of sine x y is equal to integral of cosec x, then exponent natural log of the absolute value of sine x. So what we'll do is that you know that exponent natural log is equal to 1. So this becomes y sine x equals integral of, sorry, there's a dx here, integral of cosec x then sine x dx. However, cosec x is the same as 1 over sine x. So cosec x times sine x is the same as dx. So this becomes y sine x equals integral of dx. So y sine x is equal to x plus c. So y is equal to x divided by sine x and plus c divided by sine x. So 1 over sine x is the same as cosec x, and therefore y is equal to x cosec x plus c cosec x. However, we have boundary conditions here which says that y is equal to 0 when x is equal to pi on 2. So now pi on 2 is the same as 90 degrees. Sine 90 is 1. So here 0 is equal to, wherever we see x, we need to put pi on 2. So here is pi on 2 times 1 over 1 is the same as 1, then plus c times 1. So in other words, c is equal to minus pi on 2, and therefore y is equal to x cosec x then minus pi over 2 cosec x. Solve the differential equation x dy dx minus 4y equals x exponent 6 then exponent x, given that y of 1 is equal to 1. So first thing, let's make the coefficient of dy dx 1. So dy dx and minus 4 over x y equals, now if we divide here by x, here we'll be left with x exponent 5 then exponent x. So u of x, the integration factor, is equal to exponent integral of minus 4 over x dx. So now this is equal to exponent minus natural log of the absolute value of, sorry, minus 4 natural log of the absolute value of x, which I can also rewrite as exponent minus natural log of x exponent 4. Because the power of x is even, then we don't need to bring the absolute value because x will always throw out a positive number. So now if we multiply through by the integration factor, we then have exponent minus natural log of x exponent 4 and then dy dx and minus 4 over x y exponent minus natural log of x exponent 4. Then this is equal to x exponent 5 exponent x and exponent minus natural log of x exponent 4. So you see that this is the same as d dx of exponent minus natural log of x exponent 4 then y equals, now if you multiply this you will get x exponent 5 then exponent x and exponent minus natural log of x exponent 4. So we then see that, now I want to rewrite this as exponent natural log of x exponent minus 4 y equals integral of x exponent 5 exponent x exponent natural log of x exponent minus 4 dx. Exponent natural log is equal to 1. So this becomes x exponent minus 4 then y equals integral of x exponent 5 exponent x, then times x exponent minus 4 dx. So x exponent minus 4 is the same as 1 over x exponent 4y equals integral of, now if you multiply x exponent 5 by x exponent minus 4, you get x exponent x dx. So we can use integration by parts here. So let's let I to be equal to integral of x exponent x dx. So u in this case is equal to x, then du is equal to dx, then dv is equal to exponent x dx. So v is equal to exponent x. So I is equal to uv, which is x exponent x, minus integral of v. V is exponent x du is dx. So I is equal to x exponent x minus exponent x plus the integration constant, and therefore 1 over x exponent 4y is equal to, now all of this becomes x exponent x minus exponent x plus c. If we simplify further, y is equal to, now if we multiply x exponent 4 by x, you get x exponent 5 exponent x minus x exponent 4 exponent x and plus c. The boundary condition is y of 1 is equal to 1. So wherever we see x, we put 1, and wherever we see y, we put 1. So 1 is equal to 1 exponent 5 is the same as 1, and then exponent 1 is the same as e, then minus 1 exponent 4 is the same as 1 exponent, so minus e, then plus c. In other words, this implies that c is equal to 1, and therefore the equation is y equals, sorry, I forgot to multiply the c by x exponent 4. So y is equal to x exponent 5 exponent x minus x exponent 4 exponent x and plus x exponent 4. So solve the differential equation dy dx minus y tan x equals sine 2x. So from here we can find the integration factor u of x, which is equal to exponent integral of tan x dx. So this is equal to exponent, if you integrate tan x, it's equal to the natural log of the absolute value of cos x. So let's multiply through by the integration factor. So exponent natural log of the absolute value of cos x, then times dy dx, and minus y tan x, then exponent natural log of the absolute value of cos x equals sine 2x, and times exponent natural log of the absolute value of cos x. So all of this becomes d dx of exponent natural log of the absolute value of cos x, then y equals sine 2x exponent natural log of the absolute value of cos x. So in other words, exponent natural log of the absolute value of cos x, y is equal to integral of sine 2x exponent natural log of the absolute value of cos x, then dx. However, we know that exponent natural log is equal to 1, so this becomes y cos x is equal to integral of cos x, then sine 2x dx. So let's let I to be equal to integral of cos x, then sine 2x dx. But we know that sine 2x is equal to 2 sine x cos x. So this I is equal to integral of cos x, then times 2 sine x cos x dx. So this becomes integral of 2 integral of cos squared x then sine x dx. So in this case, let's let our u, let's do a substitution. Let's let a to be equal to cos x. So dA is equal to minus sine x dx. So dx is equal to minus dA over sine x. So I is equal to 2 integral of, now cos squared x becomes a squared sine x, then dx is minus dA over sine x. So this and this will cancel out. So I is equal to minus 2 integral of a squared dA. This is equal to minus 2 over 3 a cubed plus a constant of integration c. So this means that, remember we said a should be equal to cos x. So I is equal to minus 2 over 3 cos cubed x plus c. So we said that y cos x is equal to integral of cos x sine 2x dx. And then this was y. So y cos x is equal to all of I, which is minus 2 over 3 cos cubed x plus c. However, we're giving a boundary condition that y is equal to 1 when x is equal to 0. So let's put in the boundary condition. So here becomes 1, cos 0 is 1, so times 1 equals minus 2 over 3. Then cos 0 is 1, 1 cube is still 1, so times 1 plus c. So c becomes 1 plus 2 over 3, which is equal to 5 over 3. So it becomes y cos x equals minus 2 over 3 cos cubed x then plus 5 over 3. So y, if we divide through y cos x, is equal to minus 2 over 3 cos squared x plus 5 over 3 sec x. Solve the following differential equation. X exponent 3 dy dx is equal to bracket 1 plus x squared then tan y. And they've given us this boundary condition. So now let's make the coefficient of dy dx 1. So dy dx is equal to 1 plus x squared divided by x cubed tan y. So now what we'll do is that let's divide through by tan y. So 1 over tan y dy dx is equal to, now 1 divided by x cubed is the same as x exponent minus 3. Then x squared divided by x cubed becomes x exponent minus 1. So let's multiply through by dx. So this becomes 1 over, so let's multiply through by dx. But 1 over tan y is the same as cos y divided by sine y dy is equal to, into bracket, x exponent minus 3 plus x exponent minus 1 dx. So now if you integrate cos y divided by sine y, see that if you differentiate sine y, you get cos y. So this becomes natural log of the absolute value of sine y equals, if you integrate x exponent minus 3, if you add 1 to this, you get minus 2. So you get minus 1 over 2 and x exponent minus 2. If you integrate x exponent minus 1, it is natural log of the absolute value of x and plus a constant of integration c. Now the boundary condition is that y is equal to pi on 2 and x is equal to 1. Now pi on 2 is the same as 90. Sine 90 is 1. Natural log of 1 is 0. So here 0 equals x is 1. So here becomes minus 1 over 2. Then natural log of 1 is 0 plus c. So this implies that c is equal to 1 over 2. And therefore, natural log of the absolute value of sine y is equal to minus 1 over 2 x exponent minus 2 then plus natural log of x, then plus 1 over 2. So if we rearrange and write it well, we find out that natural log of the absolute value of sine y is equal to half, then minus 1 over 2x squared, then plus natural log of x, absolute value of x.